So my name is Kunal Batra. In this session, we're going to be talking about AutoML here at AWS and a couple of other services that really help with that machine learning workflow. So just a little bit about me before we begin, just to really calibrate any of the questions or conversations that we might have during this presentation or afterwards. I'm a senior developer advocate here at AWS. If you're not familiar with what a developer advocate does, I've heard that term before. Essentially, it's just an engineer who helps build awareness and adoption of our services. I've worked in a lot of different developer-focused verticals. If you have any questions on any of those, feel free to reach out to me. At Kunal732 is by far the fastest way to communicate with me. And then my email, kbatra@amazon.com. And just a personal passion of mine, machine learning and computer vision. On that bottom left over there, created a image classification model for my parents, let them know whether the garage door was open or closed. They loved it. It was a quick app to build and fun one as well. On the right, counting how many people are in line at the Shake Shack in Madison Square Park. Another fun little one over here, just an object detection model around some household items I have too. So it's a passion of mine. If you have any questions on any of those, feel free to reach out, kbatra@amazon.com or at Kunal732 on Twitter. Okay, so the agenda today, wasn't sure about the audience and who that was going to be for this particular talk, so wanted to spend a couple of minutes on level setting and going into some of the basics of machine learning, and then kind of, if you're not a machine learning expert, some of the services we have here at AWS for AutoML, specifically Autopilot, as well as AutoGluon. And then from there, wanted to showcase some of our other services we have over here that can help speed up that machine learning workflow, as well as some of our APIs for pre-built models that we have here at AWS. So let's begin. Just to give some broader AI context here, some terminology. So essentially, for those who are not familiar, and this is your first time looking at any of these materials or terminology, artificial intelligence is any sort of computer system that can mimic human behavior. It doesn't have to be neural networks. It can be a bunch of if and else statements. Now, machine learning is one subset lower than that, and this is where you start learning with data. And you can see some common machine learning algorithms over there, and we'll talk about two of these later in the presentation. So on the left-hand side over here, you can see a handwritten program, a bunch of if and else statements. Again, this can be AI, but on the right, with machine learning, you're actually learning from data, and then with that, you can get recommendations, forecasts, predictions, and so forth. And so there are different types of machine learning algorithms here. Two of the most popular ones are supervised learning and unsupervised learning. So supervised learning takes advantage of, for example, take a look at that garage door application I built. You need a bunch of inputs. In this case, it will be the photos of the garage door, and each of these need to be labeled: garage door open, garage door closed. With unsupervised learning, you don't need to have any labels for those inputs. Now, there are different types of categories for each of these algorithms. In this case, for the garage door, that's a classification algorithm, open, closed, binary classification. But you can also have multi-class classification as well. Or with supervised learning, you can have regression algorithms too. So if you want to know, predict the stock price or predict temperature, you can do that as well. Now, with unsupervised learning, you're taking a look at things like the similarities of the attributes of the inputs and doing things like clustering based on that. So some examples of this classification, another example over here is activity detection with your Apple Watch based on the movements it's seeing. And with that supervised learning model, it can tell you what type of activity you're doing. This is all done with labeled inputs. With regression, you can also do financial forecast, resource consumption forecast as well. Clustering, again, this is taking a look at the similarities between the attributes of your inputs and clustering based on that. In this case, you can see a chart over here where you're seeing what gear your vehicle was in when taking a look at the RPMs of your engine, as well as your vehicle speed over here, and then clustering that information. So there are a lot of different types of algorithms when it comes to training your machine learning model. And if you're an expert, this gets really easy based on the type of problem you have to see which algorithm to use, or maybe which combination of algorithms to use to solve that. However, just to showcase this for those who are not familiar with that machine learning process, first you have to get that business problem, then you need to frame it as an ML problem. Over there's this classification, regression, is this unsupervised learning, and so forth. Then you go through a couple of different steps over here, right? So first is that data preparation, collection, cleaning, integration phase over here. From there, you want to be able to visualize this, analyze this, make sure it's okay. If it is, you can go forward. If not, you have to keep repeating this. Once you get there, you can do feature engineering, go through model training, and then from there, evaluate it. Ultimately, what I'm trying to showcase in this slide over here is this is an iterative process, so much so that it is an art. And if you have experience with this, this obviously gets a lot easier, but obviously a lot of newcomers coming into machine learning don't have that experience. And this is where AutoML can really help out. It can help simplify this process and help you get those accurate results. So when it comes to AutoML, you can see certain aspects of this being taken care of or with automation over here. Another way to showcase this is this flow over here, and you can see with AutoML what gets taken care of. I just don't like the iterative view of these steps. I want to make sure that people can see that, the linear view of these steps. I want to make sure people realize that this is an iterative process. But essentially with AutoML, you can take care of a lot of that heavy lifting in the background. And so we have two services here at AWS that can really help with this. One is a first-class service called AutoPilot. That's part of our SageMaker suite of tools. If you're not familiar with SageMaker, it is our suite of tools that makes it easy to build, train, and deploy machine learning models here at AWS. And I'll showcase a little bit of that later in this presentation. AutoGluon now is an open source framework for AutoML that we open sourced for our last AWS reInvent, November of last year. Now, with AutoPilot, this is strictly for tabular data. With AutoGluon, this can also be for tabular data, text classification, image classification, object detection as well. So with SageMaker AutoPilot, like I mentioned before, this is part of our suite of tools that lets you build, train, and deploy. Specifically, it's part of our SageMaker Studio, which is our IDE for machine learning practitioners. Now with Studio, you get the ability to quickly load up notebooks. You don't have to wait for any launch time. Track your experiments. You can debug your models. You can also monitor them when they're in production and get notifications if drift is happening and take some actions based on that. Plus, you have AutoPilot as well. So with AutoPilot, the way this works is you just give some tabular data. From there, you specify the column that you want to predict on. Then AutoPilot itself will then go ahead and create a pipeline where it will train multiple models in parallel. And it'll also track those models for you and showcase that and how that's the accuracy and other information. It gives you obviously automatic feature generation, algorithm selection, parameter tuning, some of the features you expect with AutoML. But it's not like typical AutoML tools where it's a black box. It does create two notebooks, and we'll showcase this in a bit. One is a data exploration notebook, where you can see analysis of your data and what we think of that and why we chose certain algorithms based on that. And then also a candidate generation notebook as well, just to give you a little bit more background on some of the results we saw, and this is why we've chosen these models for your results. So you don't actually have to even go through and train the model. You can just create those two notebooks just to get a head start on where's a good place to start training your models, just to learn from as well. So let's do this from here. Let's go ahead and showcase an example of AutoPilot. So we have this data set over here, and this is a CSV file. And essentially, this is 41,000 data points over here on customers of a bank. And pretty much all of these features over here just tell you different aspects of the customer. And at the end, you have this column Y, which tells you, did they accept a marketing promotion offer or not? You can see things like what type of cell phone number they gave, phone number they gave. Is it a telephone? Is it cellular? Do they live in a house or not? When were they contacted for this marketing offer? Some other status, some other features like marital status, education status, and so forth. So the idea over here is we're going to train a model in autopilot, in AWS, for this data set over here. So the first thing we're going to do is go to SageMaker Studio. I already have this loaded up over here, but essentially, if you're not familiar with this, just go to the console for AWS, just type in SageMaker, and you can click on the SageMaker Studio button in the following screen. Already have that loaded up over here. I have a couple of different tabs open over here. So let's go ahead and just create a new autopilot experiment. So you can see over here, create an Amazon SageMaker autopilot experiment. And essentially, this is pretty simple over here. The first thing we need to do is give it a name. So we can just call this AI Camp 2 in this case. From there, we need to just give it that data set. So we just have to tell it what bucket S3 bucket it's in, and then the name of this. So this is called bankadditional.csv. And then we need to tell it which target, which column do you want it to predict on. So the name of the column was Y in the CSV. So we'll just go ahead and say Y over here. Let me just make this a little bit bigger. It makes it easier to read. And then we need to specify what's the output that we want to, what bucket we want to put the output in. So I'll just put the same, use the same bucket over here, AIML data. And then finally, it's asking us which type of machine learning problem is this? So with autopilot, it does, like you can see over here, classification as well as regression. If it doesn't know, if it's a multi-class classification, and it seems very similar to regression, if it can't figure out which one it is, it'll ask you for it. Otherwise, it'll just go ahead and pick the right problem over here. So right now I'm going to say auto, and it's going to figure out that this is binary classification. Do you want to run a complete experiment? Yes. Otherwise, like I mentioned before, you can just go ahead and run this just to get those candidate generation notebooks, just to understand how autopilot would go ahead and start creating models for this. So let's make it a full experiment. I'm going to click Create Experiment. And then from here, it's going to do 3 steps over here. The first thing it's going to do is start analyzing our data. From there, it's going to go into feature engineering, model tuning, and then we have the ability to deploy those models over there. Nothing else was done. No other modifications were made to that data. This goes ahead and takes care of everything else. It'll go ahead and take a look at that data. It'll just make sure what features make sense, what features don't, and it'll just focus on those that do make sense. Once that is done, I will see a screen like this where there are a full, a lot of models over here that were trained, and I can see the accuracy over this. You can see that this was the best, most accurate model over here. And then we can go ahead and just right click on this and say deploy model. From here, it'll go ahead and just deploy an endpoint with that model. And then we can go ahead and predict that, use that for predictions behind an API endpoint or however else we want to use that for our purposes. So that's pretty simple, pretty straightforward to do as well. So that's autopilot. So let me go back to my PowerPoint slide over here. So again, this SageMaker autopilot is part of SageMaker Studio, that IDE I was just working in. So again, the first thing autopilot does is analyzes that data set. From there, it will go through a bunch of different items. It'll also do a data analysis as well. It'll create those notebooks to showcase what choice it's going to make. And then it's going to train multiple models in parallel to give you that best model. Now, this is something for people who are new to machine learning that I like to point out. It's a question I get a lot. Why don't I just always choose the most accurate? Obviously, latency plays a role as well. So based on your use case and what makes sense, you want to make sure you take a look at multiple factors, not just at accuracy. So that's autopilot here at AWS. Now, again, that only does tabular data. Now we also have AutoGluon, and AutoGluon does more than that tabular data. It does tabular data, but also text classification, image classification, object detection as well. Now the main thing with AutoGluon is this is also pretty simple to use, and I'll showcase that in a second. The major difference here with Autopilot is it doesn't give you that look, that peek behind the window of what's happening and why is that happening and why those decisions were made for training that model. But it does give you that simplicity and also gives you pretty good results as well. And we'll see that in a second too. So like you can see over here, this is pretty simple to use in this specific case for that tabular data set. You just need those 3 lines. Specify that data set, run the fit function, and then from there you can make a prediction. So let's just showcase a little under the hood over here. So for what's happening right now is for that data preprocessing, first it checks that label column and determines whether it's classification or a regression problem. Then it's going to go ahead and transform that data into a form that'll be consumed by many different algorithms in that fit phase. And then from there, any column that isn't numeric or doesn't repeat will be disregarded and not looked at. Now, when it comes to the fit phase, it'll start training a series of ML models based on that preprocessed data. And then after that, it'll go ahead and start ensembling and stacking, right? So basically combining multiple models to create an ensemble that has higher predictive accuracy than each of the participants as well. And then it goes into some more features where it distills, so you don't have these massive models, you have these representations of those models to try to get similar results. But I can send more information about that later if anyone's interested. Okay, so we just showcased the same data set for Autopilot, basically those 41,000 observations. It's got 20 features, binary classification. It had a 0.8% or 80% accuracy over there. Now, if we go through AutoGluon, just to showcase this, so let me come back over here to Studio. Now I have this preloaded up over here. This might be kind of hard to see. Let me just see if I can extend this, make this a little bigger. But essentially, if you can get the idea, it's pretty much these 2 lines. That's it. That is AutoGluon for predicting on that same data set. Essentially, just import the AutoGluon library. From there, just call that fit function and just give it the data set over here and just tell it the column to predict on right there. From there, you can see that it's going to start training a bunch of different models. And after that, you can see it'll have the ensemble model over here with a 0.93 for accuracy score. So that's AutoGluon. Again, it's very simplistic and very easy to use here, but the results are pretty good. I believe for this particular challenge over here, the Auto Group Product Classification Challenge on Kaggle, this finished, but if you use AutoGluon for this, you can go ahead and still submit your score and submit your results and see how you see your score in the leaderboard. It'll put you in the top 1% with AutoGluon, right? So it gives you some pretty really good results, largely due to that ensembling of those models. So if you want more resources to learn more about AutoGluon and Autopilot, you can go ahead and check out some blog posts over here. This one, AutoGluon, was the opening blog post by one of my colleagues, Shashank, who wrote about the AutoML library and gives you more examples on it. And Autopilot, it's in our documentation. So you can go to that link or just go to docs.aws and search for Autopilot as well. Now, that's really there to help simplify that process for training your machine learning models. But now let's say you don't want to train your own model. You still want to add intelligence, or you still want to automate some of that workflow. I just want to quickly touch upon how we think of machine learning here at AWS. and some of the other tools that you can take advantage of to help simplify your process. So basically, we look at machine learning here at AWS as in this stack, these 3 layers. That bottommost layer over here, these are the machine learning frameworks and infrastructure. These are for advanced practitioners who are really comfortable with at that framework level. We have separate teams here at AWS dedicated to each one of those frameworks, making it sure it runs in the most optimized way as possible on the AWS cloud. Now, if you move one level above that for the machine learning services, this is pretty much SageMaker, what we've been speaking about. These tools that really help you simplify that build, train, and deploy process for machine learning. Now, one of my personal favorite services here is Ground Truth. Ground Truth, we'll talk about it in a second, but it really helps simplify that data labeling phase, right? So using that data for autopilot or whatever flow you want to use to train your model, and we'll talk about that in a second. And then above that, those AI services, now these are models that are trained by different teams internally here at Amazon or AWS that we've since opened up as APIs for anyone to take advantage of. I showcased that garage door open or close example in the beginning. This was something I trained on SageMaker, but now we have Amazon recognition labels where you can just go ahead and just give photos and manually label that, and you don't have to worry about anything else. It'll go ahead and create that model for you. So now let's focusing on ground truth. What we hear from our customers is 80% of the time it takes to actually build and deploy a model comes into that data labeling phase. So it's a pretty big problem, and it's something that holds back a lot of our customers, right? So for many different reasons, based on different accuracy requirements you might have, or different diversity of conditions, usually the amount of data that you need is quite high. And with such large samples of data, labeling that does become an issue. So with SageMaker, and I apologize for the marketing feel of this slide, but it essentially gets the points that I wanted to get across. It gives you a couple of abilities here. It lets you quickly label that training data, and I'll showcase that in a second. It gives you access to human labelers in multiple ways that you can use to quickly label that data. It does also give you, we have some mechanisms here to help improve the accuracy that you can get from those human labelers as well, and has some cost saving mechanisms too. We'll just quickly touch on those. So one of the things that Ground Truth does is it gives you workflows to quickly label your data. So for example, whether it's object detection, classification, semantic segmentation, or more, you can take advantage of one of those workflows and then pass it off to human labelers to go ahead and label that data. If it is a workflow that's not based on one of the workflows that we have, and we're creating more than just what's here, constantly adding more. But if it's not there, for example, like audio classification or something else, you can go ahead and use these templates and create a custom workflow to solve that issue as well. Once you have that, you want to go ahead and pass it to a pool of labelers to go ahead and label that data. Multiple different types of labelers here. So you have Mechanical Turk. So this is a workforce of 500,000 strong that can go ahead and quickly label that data. It's great because it's low price, but also you have to keep in mind that this is for non-sensitive data as well. You don't want this public workforce taking a look at sensitive data. If you do have sensitive data, then you have different options here. You can use a private workforce, essentially taking advantage of this infrastructure to label data, but using your in-house experts or someone else that you trust to go ahead and label that data, whether it's for expertise or for support or for whatever else reason. You can also take advantage of third-party vendors that we have relationships as well to label that data too. And I also mentioned accuracy here as well. So one of the things that usually when I'm giving this presentation in a room, I tend to ask the crowd what dog they see over here, right? And you get a couple of answers: Shar-Pei, Bulldog, and so forth. I just wanted to simulate that over here in this slide. In this case, let's say we ask 4 people, and we get Bulldog, Shar-Pei, Bulldog. Then with majority voting, this will become obviously a Bulldog, and that's not true. But with Ground Truth and taking advantage of probabilities and a modified version of expectation maximization, which I'll just showcase in a second afterwards this, you can see that you're now taking a look at the accuracy of these labelers. And then with that, you can see that Sharpei actually is the answer, even though only one of the labelers gave that, and the other three of them gave bulldogs as well. And if you're interested to learn more about how we're working on this and how we solve this, there's a great paper here on that specific scenario and how we built that aspect of it into the ground truth. It's an expectation maximization method proposed by DeWeed and Skeen, and the paper is right there that goes into that if you're interested. And so spoke a little bit about ground truth and just wanted to talk about some of those top level services here as well. Really quickly, it lets you do some pretty fun things without actually having to train your models. We have recognition over here, and I'll just go ahead and showcase this right now. Recognition is one of our services that does pretty much computer vision. So I went ahead and uploaded this photo, and you can see that it has the ability to see everyone and give you different aspects of their face and facial features here. Also, you can go ahead and use your own webcam for this as well. So let me just go ahead and showcase that. So give it a second to load up, and you'll see me in just a second. Hey everyone, how's it going? You can see that it gives you a whole bunch of criteria over there to showcase my emotions if they're calm. Let me see if I can try to like mimic a happy face. Angry, okay. So just really quickly, that's another way to add intelligence into your application over here for that. So you can take advantage of different aspects of AWS and other models that we've opened up for your applications as well. Thank you, everyone. My name is Kunal Batra again. Please feel free to reach out to me at Kunal732 if you have any questions, or kbatra@amazon.com as well. I'll also be on the Slack right after this too, if you want to ask me questions after this presentation.
Great, thanks, Kunal. And I think we have quite a lot of questions in the Q&A. Are you able to click it to see, or you want me to read it to you?
Yeah, I can go ahead and click it. Okay, so what is the ML engine tool used by Autopilot? Is sklearn? I'm not familiar with what internally we used for that, or if that's something that's publicly available. Next, is there a model parameter tracking inversion in SageMaker, or is it possible to integrate MLflow into SageMaker? So yes, it is possible to integrate MLflow into SageMaker, and there is a bunch of great workshops that some of my colleagues run to showcase that. You do also have the ability to, sorry, did I lose my place here? You do also have the ability to track your models as well, to track those experiments. And feel free to email me, kbatra@amazon.com, if you want any specifics, or you can go ahead and just Google that or search for that in docs.aws as well. Okay. Is Gluon CV free as part of the free tier account? I don't believe so. Does Autopilot work on time series data? It works on tabular data. So I guess with, in this case, it looks like it should be able to. Could you share us the slides? Yes, I can share the slides. Bill, is there a way I can send you the slides? I believe I did send a previous version of the slides. Should I just upload it there and then you'll send that out afterwards?
Yes, you can just upload it to the G Drive, and I will share to all attendees.
Okay. And then which tool would you recommend to design a model to detect human action? Window cleaning in a shop. You can take a look at recognition labels. That would probably work with that really well. It's pretty simple to do that. I guess the main thing over here is you want to get that data and you want to make sure you label that properly with ground truth. And then from ground truth, you can automatically plug that into with SageMaker and our other training capabilities. Does SageMaker have hybrid cloud capability? I don't believe so. I think I might have missed a couple of those questions. Feel free to email me as well. You can check out pricing on the SageMaker website. for different aspects of it. There's a lot of different features and services for that. How is model explainability provided in AutoPilot or AutoGluon? It is not provided in AutoGluon, but it is provided in AutoPilot. In AutoPilot, you have the ability to just go for model explainability and see why we do what we're going to do. Or you have the ability to fully see why we're going to do it and then the end result of that as well. We give you two notebooks. Let me see if I can just share my screen again and showcase that. So once it is, you can see these two notebooks on my screen over here. Once you go ahead and start training your machine learning experiment, your autopilot experiment here, you can click on each one. Your data exploration notebook, which gives you analysis of your data, and also the candidate generation notebook, which tells you why it's picking the certain types of candidates to train your models with. How's this going? Great. I see some of my colleagues here are already answering questions as well. If I missed something, feel free to email me, kbatra@amazon.com.
I think in the top, in the Q&A in the top, there are a few questions. I'm not sure it's being answered, or maybe you can just quick double check at the top of the Q&A.
Okay. Yes. So I see for any special treatment for unbalanced data, I see Chris sent a link on that.
Oh, that's
class
great.
imbalance. Yeah. And then is there a way to track the data version that was used to create the model in SageMaker? Yes, you can track it with SageMaker experiments. Has anyone came across a data set pre-trained in SSBB with really good accuracy with a variety of labels? I'm not familiar with that. How is model explain provided in AutoPilot or AutoGluon? I just went over that with the candidate generation notebooks. Pricing details can be found on the SageMaker site. Is recognition or any other AWS models good at recognizing emotions? I'm working on a product to help people improve emotional intelligence health. Yeah, I just showcased that. You can use recognition to help recognize emotions. What are the top industries or / use cases that use AWS AutoML? Oh, that's a good one. I'm not sure about that. Whatever is good for your particular use case where you want to take advantage of seeing how AutoML can help give you better results. But I'm not familiar. It's everywhere, right? You can find ML in every industry, healthcare, automotive, anything you can think of. How much data is needed for recognition ML models to be effective? Again, it depends on your use case. It depends what you're trying to do, right? You know, if you're trying to build a self-driving car, you know, you want to make sure that you have as much accuracy as possible. So yeah, it's very selective and depending on what you're trying to do. Great. Thank you, everybody.
Okay, great. So we are right on time. Thanks.